All right, so you've made it through a bunch of proof stuff, trying to catch what's going on. You got some weird old dude explaining it poorly. Now let's do some example problems, and hopefully that shorts up the gas, because you're not responsible for the proofs. You're responsible for knowing how to use them. Okay, so there's our geometric series one more time. We're going to use this formula that we have, where we're going to need to find some A. We're going to need to figure out what R is, and then we're going to see if the series diverges or converges, but we can also solve for these bad boys now. So we're going to evaluate the following geometric sum. So let's start with the first one. So let's zoom out a little bit and go, okay. Let's see what's going on. And we're like, it diverges. Why does it diverge? No work needed. I don't need to do anything. I just look at the damn thing. I want to list what's A and what's R. A isn't written. It's 1. See? It's right there. And what's R? R is the thing inside the power. That's equal to 1.7. But 1.7 is clearly greater than or equal to 1. Therefore, it diverges. Done. Done. So our game is find A, find R, use formula. All right. Let's go to our next one. All right. There we go. So what's A? What's R? Well, hold on just a second. I do not like that negative exponent. That thing's bothering me. That's the trick to this problem. Because our formula doesn't have a... Is there a negative k up here? No, this formula works for a positive k. So let's change that thing right away. Be like, no, no, no. No, 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 no. From k equals 0 up to infinity. This is 1 over e raised to the power of k. Hey, there we go. So our A is 1 and our R is 1 over E. Well, E is a number between 2 and 3. 2.71828, blah, 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 goes on forever. But that's in between negative 1 and 1, isn't it? So this is saying it will converge. So we just need to be able to plug it into our formula. So it's going to be A over 1 minus R. No biggie. No biggie. So we're saying this is going to be equal to A over 1 minus our R. I'm going to clean it up just a tad because I don't like complex fractions. So it's going to multiply by E, and we find out that this goes to E over E minus 1. And if you're interested, you're like, it goes to 1.582. So as we add those up, we're just ending up with numbers that are getting smaller and smaller and smaller that we're adding up. Yeah, buddy. Yeah, buddy. Sums, adding numbers up. Let's go to number 3. Okay, so, all right, k starting at 0. We got 3 times. So, all right, so let's go through it. Let's see if we can't solve this one out real fast. Again, let's find A. A is just the coefficient. That's the 3. And our R is equal to negative 1/2. So our formula states that this must equal A over 1 minus R as long as our R is in between negative 1 and 1. We're going to actually get an answer. So let's pop it in. Let's see what we get. So we got our 1 minus, so we're going to get a 3 up top. We're going to get a negative 1/2 down below. A negative 1/2 down below. So what do we end up with? 3 over 1 plus 1/2. I think that's 3/2. So this is 3 times 2/3. Cancels out, and it's just 2. Wow, that's convenient. It's just 2. That's a pretty small number. Just to go to 2. With infinitely many terms. Dude, go add up small-ass little decimals. Go save a bunch of pennies. You do it long enough, you end up with some bucks. We only ended up with $2 here. All right, let's do our last one. It's very similar. Look. It's damn near the same problem. The only difference now is we're starting at 2. And we don't have a formula for starting at 2. We have a formula starting at 0. So we're not going to get the same answer. I'm guessing it's going to be a little smaller, maybe a little bigger. That's a negative. I don't freaking know. We're going to start on the second term. We're not going to start on the 0th term, which is 3. We're not going to start on the first term, which is negative 1.5. All right, let's see where we're going to end up. So let's write out some terms first. We're like, okay, well, this is going to be 3 times negative 1/2, and we start at 2. Plus 3 times negative 1/2, and then we're going to be at 3. Plus 3 times negative 1/2, and then we're going to be at 4. Plus ... And it's just going to keep going, right? Well, I want this to start out like this. I want this to look like a to the r. A to the r squared, and so forth. I wanted to set it up in that way, the way that we've been doing this work, where all of our terms should turn out this way. So what we want to do is, hey, if that's a, look, it's telling you, that's a. Factor it out to the front. And now we have 1 plus 1 plus. Hold on. I think it got a little weird there. Wait a second. We don't have to do that. Wait a second. We don't have to do any of that. I don't have to get crazy. Look, if the first term is a, and that's how we want it each and every time. We want it to be a as our first term. It's telling us a is equal to 3 times negative 1/2 squared, or it's 3/4. And then what's r? Can you figure out what r is? It's negative 1/2. Look, it's right there. It's an r. It's negative 1/2. So by setting up the first term, we had to get this thing ready because we're going to infinity here. We started at 2, which means we skipped our first 2 terms. So we can't use that formula. Here's as tough as it's going to get, it's not going to get any tougher. That is the frickin' trick. So we're going to say that this actually equals our a, which is 3/4, divided by 1 minus our negative 1/2. So we're going to get 3/4 divided by 3/2. This equals 1/2. Oh my goodness. It equals 1/2. Once again, I kind of tried to tell you what the answer was going to be. Because we lost our first 2 terms, right, from this. This problem turned out to be 2. This problem turned out to be 1/2. But if you looked at the first 2 terms of this, I told you if you just plugged in k equals 0, you're going to get 3. If you plug k equals 1 into that, you're going to get negative 1.5. What's the difference between 3 and 1.5? It's 1.5. How much smaller is 1/2 than 2? It's 1.5 smaller. We just took out the first 2 gosh darn terms that we're adding up. So it ends up being a little bit smaller. That's our game. This is a geometric sum, or a geometric series. We're going to start messing around with how we can take repeating decimals, turn them into fractions by using sums in our next one. All right, see you then.